我们邀请到 Lucy World 首席科学家 Grant Ingersoll 为我们主讲。Let's welcome Grant Ingersoll with a warning clap.
Thank you. It's my first trip to Taiwan, and I'm been having a great time so far, and hopefully I can return the favor by giving you some information about machine learning and how maybe you can use it in your lives, and then also how get into a little bit around the use of Mahout, which you just saw some preliminary videos around. So as she said, my name is Grant Ingersoll. I'm the chief scientist and co-founder of LucidWorks. We primarily are in business around supporting Lucene and solar technologies. I'm also the co-founder of the Apache Mahout project and on the project management committee there. So let me start off by, anybody in this room using machine learning? So I would put forth that all of you in this room are using machine learning. Anybody here use Google? You've heard of it? Yeah, I think so. Search uses machine learning all the time. They're constantly, you are part of the machine that is machine learning, right? You are contributing on a daily basis to the way Google works and how it contributes and makes for better search. Anybody use Google Translate? I had to. That's all machine learning. And in fact, the strides that Google has made in statistical machine learning around translation are very, very significant, and others in the field as well. Anybody use priority inbox in Google? That's also machine learning. I'm going to talk about a lot of these features and functionality as we go throughout here, and how there's open source tools that help you with this. Facebook, Twitter, LinkedIn, everybody's using machine learning these days. It is probably one of the defining ways that we will be able to deal with the onslaught of information that we have. Just to give you a little bit of definition around it, it's not my definition, but I think it helps take some of the mystery or the magic out of machine learning, because I think many of us, when you first hear or think about machine learning, you think, oh, these machines are going to take over the world from us and all of that. But in reality, all we're really doing with machine learning is looking at the past and using that as a predictor of some current or future event. Okay, so there's a whole lot of counting going on and a whole lot of statistics and linear algebra and all of that stuff. These are all things that you guys know already. So machine learning is just applying those and trying to make those fast and doing it on a whole bunch of data. There's lots of related fields for machine learning. Things like search, information retrieval, statistics, biology, linear algebra, all of those things can help you be better at machine learning. So go back to your college days, get out your linear algebra book, get out your stats book, and then you can be ready to contribute to machine learning. So my talk says I'm going to talk about scalable machine learning with Hadoop, and if you noticed in my first slide, I modified it a little bit to say most of the time. So I'm not going to talk solely about using Hadoop in machine learning, but I'm going to talk about it most of the time. And so first and foremost, one of the things we like to think about is what does actually scalable mean to us? And primarily the first bullet gets at the definition there, which is we want to be able to grow linearly with either the amount of time it takes per the data or the number of machines that we can throw at the problem. And so it gets really interesting, and I think Andrew's talk helped with his discussion around yarn and the different distributed computation models. This also applies in machine learning, right? Many of the algorithms that we have in machine learning that are effective, they take on various different ways of scaling. And so our goal in speaking of Mahout and thinking about scalable machine learning is how can we be as fast and efficient as possible given the designs of the algorithm or the requirements of the problem. So some algorithms you're going to be able to very easily put onto Hadoop and do them in a MapReduce fashion. Others, you're going to have to use different distributed techniques like MPI or some of the yarn capabilities. And still others, you may not even be able to do on a distributed cluster. And in fact, one of the fastest classification algorithms in Mahout is not parallel at all. And I'll talk about that as we go. Yet it's very effective and scales very well when you put it on a number of different machines, but they're all acting independently. So at the end of the day, just like with anything, the reason why you have a computer science degree or whatever is, and why you are a computer programmer, is your job is to make the practical decisions as to what's effective, not just go and be a slave to the actual tool that you happen to be using at that time. So what are some common use cases? Whenever I talk about machine learning to laymen, the very first thing that comes to mind is Arnold. When are the machines going to take over the world? And while that's a really nice Hollywood fantasy, I don't think it's all that practical just yet, and hopefully not in my lifetime either. So one of the first use cases for machine learning is machine learning can help you find love. Machine learning is used a lot in online dating, in matchmaking, in recommendations, et cetera, et cetera. So essentially taking all of your personality traits that you choose to enter into an online dating system or onto your e-commerce site or whatever, and use that to match you up with another person who you might like, or find you the right product, so on and so forth. So recommendations is one of the keys. This is probably a little bit hard to read, but I think when you look back at it, you get a good visualization. This is actually a visualization of somebody's LinkedIn network. And essentially, it's a clustering problem showing, given this person in the, where's the pointer? Given this person in the center, how do you cluster and group the various people that that person is related to? So I think this is actually DJ Patil who's the chief scientist at LinkedIn. These are all the people he knows at LinkedIn. Here's all the people he knows at Yahoo and on various Yahoo teams. He probably went to Carnegie Mellon, so he knows a bunch of people at Carnegie Mellon. And so this is a nice way to kind of take a high-level view of what's going on. And that's an example of clustering. I'm going to talk more about that. You can do these kinds of things in Mahout. Anybody here go shopping? Shopping cart analysis is another common one. What we're trying to find here is basically, and I think there was actually a video at the beginning here talking about the strawberry shortcake, being able to look at what everybody has in their shopping carts or in their baskets and try to figure out what patterns are in there such that we can then go and better target people. You either find this really scary or you find this really cool, depending on which side of the opportunity you're on, perhaps. But make no mistake, all of the retailers out there who are doing large-scale e-commerce are using your data every day to try to figure out how to better sell you more products in the future. Hopefully you can read that. It's a button that says cybercrime. This is another common area in machine learning. Essentially, banks and anything having to do with money or crime, law enforcement agencies, et cetera, governments are using machine learning to try to find fraud, to try to find people who are doing nefarious activities or criminal acts. And so machine learning is used all of the time to do that kind of thing as well. Last but not least, if you're on Twitter, you know that Twitter, for instance, is constantly showing you what's trending. This is a common way to find out, hey, what's going on in the world right now? This is a snapshot from my Twitter trends as of, I think, yesterday. It also has the little feature in here of another machine learning technique, which is they are also showing me an ad for a specific trend, and so they think that this might be a trend that I might be interested in, so they've promoted that up, right? So we've got trends analysis, and we've also have a classification problem in there, and that we're looking at ads as well. So those are just some common use cases that we see out in the broader uses of machine learning. When I think about what I'm doing with machine learning, my background, as I said earlier, is primarily around search, natural language processing, how to give people better access to content, essentially, how to help them solve these kind of data-driven, text-driven applications. And so for me, we kind of have this running theme of search, discovery, and analytics, that we want tools that allow to better understand, have better access to their content via things like search, but then also help them find and understand what is in that content. So my uses of machine learning tend to be around how can I improve relevance in search, how can I give users recommendations based on the content that they've looked at in the past or what their peers are looking at, so on and so forth. I also want to show them related items. So for instance, when you go buy the new iPhone, that you also need to buy the new Lightning connector to go with it, being able to do that kind of thing. I also look a lot at being able to find phrases, being able to find topics and content. Essentially, what are the useful ways of summarizing content so that we don't have to go and look through all of it, read every last document in order to understand what it's about. By the way, I would love to hear what your use cases are too if I haven't covered any of them, but I think generally speaking, those are the high-level features. So now let's think a little bit more about how do we actually scale this stuff. We've heard several times already about how much this data is growing, and I think that machine learning is one of the few ways out there that you're going to have an effective tool for helping you find the patterns in that data, helping you deal with the massive amount of data that there is. So first and foremost, I know all of this machine learning stuff is really, really exciting, and there's a lot of fun math in there, and there's a lot of really interesting programming in there, but you're going to spend a whole lot of your time in dealing with machine learning around the ETL layer of this, also around things like feature selection and post-processing of your results. If nothing else, machine learning is a lot of experimentation, so have that going in to your problem before you even start. Otherwise, you're going to be sorely disappointed that the first time you run a classifier that the results are no good. Last but not least, simpler is usually better at scale. I think this holds true across most problems, of course, but especially true in machine learning. So what are some ways that we can scale out machine learning? Since all of our work is, or a lot of our work is around this ETL layer, one of the simplest ways and one of the best ways to leverage Hadoop, I think, is by doing all of the prep work in parallel in Hadoop or in a distributed system. And then you'll go and sample, or sometimes called downsample that data, and then just run them using the good old-fashioned sequential algorithms that we already have, or maybe you at least run them in a replicated environment, so it's not distributed, but it's replicated, so you can at least scale out with the number of questions that you need to ask of the system. This actually can be quite effective. Hadoop is really, really good at this kind of stuff, and there are tools that can help you with this. And there's lots of good open source toolkits out there already that do sequential. I think, in fact, one of the professors here in Taiwan puts out libsvm, if you're familiar with that one, quite a popular classification tool. So you can go and use that. Number two, Hadoop. In the very early days around MapReduce, Andrew Ning and a few others from Stanford published a paper on multi-core MapReduce processing for machine learning, and they put forth 10 algorithms that work well on Hadoop MapReduce, and they went off and implemented them. It actually was the foundation paper for the Mahout project. We took that paper and said, hey, wouldn't it be great if we could do this at Apache? And off we went, and that's where we are today. Well, actually, we've gone well beyond that today, but that was the start. Another common approach, and is perhaps similar to the first one, but I think it's a little different in that what you're doing is actually an ensemble approach. We're going to take and we're going to distribute mini sequential models. You can actually do this in Hadoop too, where you essentially have map tasks that are load up their models, and then as the data comes through, you're just outputting them. And then you may even use some parts of the reduce phase or the shuffle to decide which one of those techniques is actually the best one. So there's a couple of different variations around this. And then I would be remiss if I didn't also say that this space is rapidly evolving, and we heard a lot from Andrew about iterative algorithms. Many machine learning algorithms are iterative, and so other tools like Spark and MPI and BSP-based Giraffe type tools can also be quite effective here. So again, just don't feel like you have to do all of this in Hadoop all the time. Hadoop is not always the right tool, but it is often the right tool. And so we should keep that in mind as we go forth. My personal thinking about, I mentioned there's a number of sequential machine learning toolkits out there. There's actually quite a large number of open source machine learning libraries out there. Some of them are more focused on scalability than others. Some are more focused on doing the latest cutting edge things. And others are focused more on what are the tried and true techniques. Probably the main ones that I think are focused on scalability, doing really large data sets are these first three. And R mainly is doing it through its integration with Hadoop. And I think there's an R talk later, and I would imagine that they would probably at least talk about some of the capabilities you can do there. And then there's a whole bunch of other ones. These ones tend to have been around a lot longer, so they have a lot more tool sets and tools for that make it easy for you to employ machine learning into your applications. And go look out on GitHub or SourceForge or wherever, and there's a whole host of other projects. So these are probably the places I would start, but you can easily go and find ones that are specifically tuned to specific problems. So with that in mind, as the Mahout co-founder, I guess I would be remiss if I didn't talk about Mahout at a talk I'm giving on machine learning. So just real quickly, Mahout is an Apache project. I guess we started in 2007 or 2008 with the sole goal of creating scalable machine learning libraries under the Apache software license. And so you might ask, well, if there's all these other projects out there, well, why did you guys bother? And there's really a few reasons. Many of the other ones at the time when we started this had a number of gaps that we felt we could solve by doing this at the Apache Software Foundation. One, they lacked community. It was hard to get help from people. Apache is, if nothing else, Apache is very good at building community and helping you get at your, understand the code. They lack documentation and examples. Now, some of those projects have gotten a lot better. Most importantly, they lack scalability. They were only ever designed to run on a single node, and thus they did not scale very well. And then for me personally, they lack the Apache license. Not always a big deal depending on the company you work at, but personally the companies I've always worked at, they more or less restrict us to Apache or Apache-like licenses like BSD, et cetera. And last but not least, and this is not to discredit them in any way, shape, or form, because this is really where the cutting edge stuff gets done, they were research oriented, and so they weren't necessarily optimized for you to deploy into a production system. And so we went off and decided, let's try to solve all of these things, and thus Mahout was born. If you're not actually familiar with the term, the Mahout is the person who takes care of the elephant. So originally the genesis of the project was we were going to be all based on Hadoop, but that's no longer the case. But anyways, our logo lives on as being the person who's taking care of the elephant. Some slides around who uses Mahout. Large variety of users, many of them household names. You can go find out more there. And I think I've met a number of people in Taiwan already who are using Mahout too. So, one of the things that nobody covered about contributing to open source, and is actually very, very helpful, if you can go add your name to the Powered By page, and I know HBase has them, pretty much every Apache project has it, by adding your name, you're at least giving that vote of confidence that yes, we are using this and it's in production, that is very useful, especially for a young project. And it can really help build community because they say, oh gee, you know, Trend Micro is using X. I know Trend Micro, I like what they're doing, I'm going to go look at that as well. That's what helps build the community and helps move the community forth. So even if you're not answering questions on the mailing list or you're not changing the code, at least tell us you're using it because that is really helpful. So what can I do with Mahout right now? I like to put these into essentially 4 categories. I'm going to talk about the 3 C's, clustering, collaborative filtering, and classification. That's a mouthful. And then we've got a whole bunch of extra stuff that you may find useful even if you're not going to use the 3 C's. So first off, collaborative filtering. You know this better as recommendations. How do I build out recommendations? In other words, how do I, when a customer comes into my site, how do I give them alternate things that they might be interested in? This is a snapshot of some of my recommendations from Amazon. You can guess what Amazon thinks are my interests. They're all about machine learning and natural language processing. The cool thing about Mahout is we have a quite extensive framework for building your own recommendation engines. And if there's anything that's most popular in Mahout, I would say it's the recommendation engine at this point in time. It by far and away has the most support and the broadest implementations of ideas around recommendations. Primarily, recommendations fall into 2 categories, one being user-based and the other being item-based. The ideas here are essentially whether you're looking at users first or you're looking at items first. User-based, generally speaking, doesn't scale as well as item-based, so most large-scale implementations are item-based. I'll leave it to you to go look up in more detail around those. We also have, interestingly enough, both online support for recommendations. In other words, you can deal with recommendations as they come in and update the model right in line. And then we also have offline support, and the offline support we can leverage Hadoop with. So the online support, roughly speaking, scales to about 100 million ratings or recommendations or however you want to think about it. And then the offline support, because it leverages Hadoop, can scale to much, much larger instances. And then once you start to look at that's your model that you use for some extended period of time, where period of time is measured in minutes, perhaps, or maybe hours or days. Mahout has both Hadoop-based implementations and sequential implementations. On the Hadoop side, we've got kind of this is again where most people start around naive Bayes. This is a really simple machine learning algorithm, but can be pretty effective in many situations. The math is really easy to understand, so if you want to get started in Mahout, that's probably a good one to learn. And then we have a variety of other ones, decision forests and some clustering-based classification. And then probably the main algorithm that we use on the sequential side is called logistic regression, and specifically our implementation is called stochastic gradient descent. Again, another mouthful, but this is in fact probably the main workhorse of Mahout classification these days. And I'll simply just point to this quote up here from Mahout in Action, which is talking about stochastic gradient descent. And essentially you can see that Shapitumi, that this system using stochastic gradient descent allowed them to do millions and millions of classifications per second. That's a lot of classifications. Most of us don't live in that kind of world, but if you're in the ad space, you do ads or targeted advertising, then you're usually talking about a classification system that is along those lines of volume. And then we have a few other implementations as well. The hidden Markov models is also a pretty popular machine learning library. Winnow and Perceptron, these are less commonly used, but mostly there as, I think, reference implementations at this point in time. So one of the things that I've been working on recently is about how do I scale out this stochastic gradient descent classification. And so what I've put together as part of, this is part of our product. I'm not going to talk about our product too much, but in essence, what we are looking at is how do we, given a number of models in a system, how do we scale this out so that a lot of users can do very high volume classifications along the lines of the Shapitumi example. And so what we've put together, and this is also described in Mahout in Action, although we've made some advancements on it. Roughly speaking, what we do is we do our training offline, although we are working on adding online training as well. We take, and this is where Hadoop comes in, we store our models into HDFS so that they're available for any node to be able to go get them. And then essentially we have 1 to n classifier nodes, and each of those nodes can load up 1 to n models based on the amount of memory and bandwidth, et cetera, that they have. And then we register all of those models, their existence, where they're located with Zookeeper, such that when an application comes in and says, hey, I need to classify something, we have a routing layer that says, okay, where does that model live? Go send the request off to that classification node and then spit back out the results. So this is really effective for doing things like the SGD, the stochastic gradient descent modeling, because those models tend to fit in memory, and they also are running sequentially, and so this works quite effectively. Probably longer term, as we add more of the Hadoop models, you'll also see that we'll have some ability to plug in and talk to Hadoop there as well, so that you can do more batch-oriented classifications where you say, here's 100 million documents, go classify them for me all at once, where this is more of a real-time classification system where you have an application that's constantly asking for classifications as they come in. So that covers the 3 C's, if you will. And I mentioned there's a number of other features in Mahout. First and foremost, so Mahout has these 3 C's, and that's our primary focus, but you may not care about those, or you may want to go implement your own. And so when you start to think about how do I program one of these applications, you start to realize that you need a lot of really fast stuff that is very memory efficient. And Java is not always so good about that, especially if you're dealing with objects. And so one of the first things that we had to do was we needed primitive collections. We needed to be able to do ints and floats and doubles and all of that, using them in a collection-like interface, just like you would use a big integer or a big double collection from the Java class libraries. So we have an implementation of that. It's very fast. What this gives you is very fast, memory-efficient ways of dealing with large volumes of numbers, et cetera. We also have a very extensive math library. So the underpinnings of all this machine learning stuff is statistics and linear algebra and math. And so you need things like vectors, you need things like matrices. We've got all of that already written out. We have a number of decomposition techniques, a number of statistical tests, et cetera. So you can just go call them via our Java APIs and be off and running with your application. We've done a lot of work to make sure that these are fast, and we've done a lot of work to make sure that they're useful for people. So if nothing else, you can go get the Mahout.math Java library and go off and start on your work. We also have a number of different ways for you to help essentially represent your content as vectors. If you're not familiar with machine learning, essentially a lot of it comes down to representing your data item as a vector or as a set of features that you want to do something with. And there are a number of different techniques that are effective in machine learning for doing that. So we've built out a number of those. We also have what is another common workhorse, if you will, in machine learning, which is called singular value decomposition. This is a Hadoop-based implementation of singular value decomposition. Essentially what SVD allows you to do is take a really large matrix and make it smaller. Okay? That's really useful because when you've got 1 million products and you have 100 million users, even with a tool like Hadoop, you can go off and crunch all of that, but it's still going to take you a long time. And what SVD allows you to do is make that really big matrix smaller. And by it being smaller, you can deal with it more effectively and faster and all of the good things that come with being smaller. And the nice thing about SVD is usually you only lose a little bit of the information. So it is a lossy process, but you usually are keeping a lot of the good stuff and only getting rid of some of a little bit of the good stuff, and you're also getting rid of most of the bad stuff. So that can be quite effective in helping you deal with things at scale. We also have some tools for frequent pattern mining or association rules. These are essentially allow you to look at transactions and count co-occurrences in transactions. Often used to do that basket analysis or shopping cart analysis. It's also often used to do things like, say, people in a given session, people who search for iPhone also search for iPad, right? And then you can surface that kind of information up and out to the user. Collocations or statistically interesting phrases, being able to take a whole collection of text-based content and find words that co-occur together in a particular document more often than you would expect them to occur in the broader context or in a normal situation. Phrases are really useful for improving search and access to content. They're also good for summarizing the way information about documents, and so those can be quite effective in text-based applications. And then last but not least, we have a whole bunch of tools around getting your data in and out of Mahout. Okay, so we have integration with Lucene, we have integration from just plain text files, from sequence files, and so on and so forth. On the recommenders side, we have support for storing the recommender model both in Cassandra and MongoDB. And I believe there's some people in the community who are starting to work on HBase as well, so there should be HBase support in the not too distant future. And then, you know, there's a whole bunch of other, like, essentially utilities that you can plug into and work with. So everybody's always asking me what's next for Mahout, so I'll just jump into that right off the bat here. Really, in many ways, the community is focused around getting towards a 1.0 release. And so we're not necessarily taking on a lot of new algorithms at this point unless they're really well baked and they've got people who are going to stand behind them and are providing test cases and documentation and all of that. But that being said, we do have a couple new things that I think will be coming in the near future. One is a new algorithm called streaming k-means. So you remember I said that those clustering algorithms often, because they're iterative, they're slower. Streaming k-means, the nice thing about it is it's only one iteration, and the quality of it is, I believe, and it's been a while since I've looked at it, but I believe is on par with k-means, or at least right around the capabilities of k-means or other clustering algorithms. And so it's like 100 times faster than the existing k-means. We also, our HMM, or hidden Markov models, those are all sequential now, and it turns out, as far as I understand it, the algorithm itself doesn't distribute all that well. But the training for HMMs, you can, there is a patch that is nearly complete in Mahout that allows you to do training of MapReduce, of the HMMs in MapReduce, and so that could be quite effective. For, again, that kind of gives you that, use Hadoop for doing all of the training and upfront data processing, but then the models that are output, make them a lot smaller so that you can just treat them in a sequential way. That's pretty effective. And so, last but not least, you know, as you get towards a 1.0 release, you want to make sure that all of your APIs are really solid and that they're documented and all of that. So we are working on essentially cleaning up the code, making sure the APIs are good, et cetera. And this really is, to the question earlier about how do I contribute. If you're just coming into Mahout and you're starting to kick the tires, come and give us feedback, come and give us code that helps to clean up that stuff so that we can have a good solid 1.0 release. And so I think that's about it, and hopefully I will help us get back on schedule. If you want to get in touch with me, I'm available at these various places. And I've written about a number of these in my book, so I'll have a shameless plug for my book here as well, which should be actually out in print in the next month or two. So with that, I'm happy to take questions. No questions? Anybody using Mahout already?
Excuse me, I have two questions. Would that be okay?
Yep.
All right, my first question is, kind of people in the past performing 3Cs over the traditional data warehouses, are you referring to that in the future? For example, things like Hadoop will eventually replace the traditional BI solution, or you see them work side by side? And my second question actually regarding one of your slides, just probably about a few slides back, and you're showing that classification model. And there are a few, I think at the bottom layer, I see the models you built on the HDFS. Could you elaborate more on that? I mean, how these models are built, or what these models probably look like?
Okay, so let me see if I can rephrase. The first question is how machine learning relates to traditional data warehousing and BI. Is that right? Where is the speaker, by the way? I'm having a hard time. Okay, so could you repeat the first question again?
Well, because since you mentioned 3C, well, as far as I remember, a lot of 3C were performed in the past over the traditional warehouses. And for the new solution, I think a lot of them are actually kind of transferring over to the new platform like Hadoop. Do you see Hadoop eventually replacing the traditional data warehouses, or do you see them kind of working side by side in the future, probably in the upcoming years?
I mean, I'm not a data warehousing expert, but from what I've seen in the space, I mean, it's evolving very rapidly. I shudder to think that Hadoop is just data warehousing 2.0, because I think there's a lot more opportunity than just being data warehousing. In particular, like, you know, some of the things we're working on is how do we integrate search and other and machine learning into these kinds of things. But you know, I think there will be plenty of companies who are building next generation data warehousing. I think they already are on top of Hadoop. And then I think there's plenty of companies that are going to just look at how they can scale out their existing tool sets. So in many ways, it's going to depend on the vendor, et cetera. But yeah, I'm not an expert on data warehousing, so I don't follow that space that much. Is that helpful or not at all?
Actually, that's very helpful. Thanks.
And then the second question was around loading the models, like how this works.
Yes, like how these models are built and what probably these models will look like.
So for our first implementation, all of the models we do, it's essentially up to you, the user, to build the models offline. These are just Mahout's SGD models. It's very well documented how to go and build these. Actually, in the Mahout in Action book, they tell you how to build these models. But essentially what you have is there's usually 2 steps in building a model for classification. The first step is, well, actually maybe 3 steps. The first step is that you need to go get a whole bunch of data and you need to annotate that data with the labels that you think are appropriate for that application, right? So classification is typically a supervised machine learning project. So you take all of your data, you have your user do, or you have somebody in the company or whatever go and assign labels to some subset of that data. So that creates a training and a test set. So now you have all of this subset of data that is labeled. You take and you split that into 2 groups. One is your training data and one is your test data. And then you go off and you run, like in Mahout, there's an API call that's just train, and you pass in a vector and the label. So you say, here's the label that we know this item is, and here's the item. And then you just keep feeding in all of your training data to the system. Okay, and then that will build up the model. You then take that test data and you run it against the system, and you say, because in the test data you know the answer and you know the data. So you say, here's the data. Hey model, you tell me what the answer is, and then you compare the 2. And if they get them right, then you give it credit for getting right, and if they get it wrong, you say, hey, if it gets it wrong too often, you say, no, that's a bad model, or I did something wrong, and then you start over again. Okay? So then once you've done that, you've essentially figured out, hey, this is the right model that I want for my situation. And again, it's not going to be perfect. Then that gets put into HDFS. You can assign labels to it and all of that. And then we load them up into memory at runtime so that we can serve up requests for those models. Okay? Some of the other things that you may do at training and test time, you don't have to just have 2 groups, one for training and one for test. You can essentially mix them up together, or you can essentially think about partitioning it into n groups, and then for you do a series of runs where the first n-1 partitions are used for training, and then the last one you use for testing, and so then you go on down the chain that way. Any other questions? Okay, thank you.
Thanks, Grant Ingersoll, for his presentation. 谢谢 Grant Ingersoll 所带来的精彩演说。